Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this complete CCNA course. I'll include the link in the description. Also remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. Up to this point, we've done several examples of subnetting Class C networks, and hopefully you've got a good handle on that now. In this lecture, we're going to take it on a stage by subnetting larger networks. So we're going to look at subnetting our Class A and our Class B networks. So let's say for our first example that we've been allocated a Class B. The IP address is 135.15.0.0/16. That's our network address. And if we subnet that into /29 subnets, we're going to have 3 bits for host addressing because we've got 32 bits in the address. 32 minus 29 gives us our 3 bits. And that will allow us 6 hosts per network, because 2 to the power of 3 is 248, minus our 2 gives us 6 hosts. So a /29, that's going to give us 6 available hosts per network, whether we're using a Class A, B, or C. It's going to be the same for all of them. Here, because we were allocated a Class B /16 range, we're going to have 13 bits for the network address. If it was a Class C, we would only have 5 bits for the network address because it's 24 to 29, a difference of 5, that would give us 5 bits. With a Class B, we've got those extra 8 bits, so 5 plus 8 gives us the 13 bits. And that is going to allow a total of 8,192 subnets. Let's count that up as well. So 2 to the power of 13, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1,024, 2,048, 4,096, and finally 13, 8,192. For the IP address 135.15.10.138/29, what would be the network address, the broadcast address, and the range of valid IP addresses? Okay, you know the drill by now. Please pause the video, figure that out, and we'll come back with the answer. Okay, here's the answer. So the question was, IP address was 135.15.10.138/29. What's the network address, the broadcast address, and the range of valid IP addresses? We'll write this out the same way as usual. So we write out the IP address and the subnet mask. We put the line in after the /29, and the line is going in after the 8. You can see here, if you look up in the top right, that we've got 1s under the 128 and the 8. So we add those 2 together. 128 plus 8 is 136. So the network address must be 135.15.10.136. The line is after the 8, so we add 8 to 136. The next network address would be 135.15.10.144. And if the next network address is 144, then the broadcast address must be 135.15.10.143. And the valid addresses for our hosts fall between the network address and the broadcast address. So that's 135.15.10.137 up to 142. Okay, another popular way of calculating the network address, the broadcast address, and the host addresses is by using the magic number method. You'll see this being cited in quite a few places on the internet. This one is very handy if you've been given the subnet mask in dotted decimal notation rather than with a slash. In that case, you can usually figure it out in your head. So a /29, if we wrote that out in dotted decimal notation, it's 255.255.255.248. And what you do with the magic number is you take the value in the octet that is being subnetted, so 248 in this case, you take that away from 256. So 256 minus 248 gives you 8, and you know that the network addresses are going to go up in blocks of 8. In our example, our address was 135.15.10.138. So we find which block of 8 is closest to that. So 10 times 8 is 80. Another 5 times 8 would be 40. Add the 80 and the 40 together, that gives us 120. The difference between 120 and 138 is 18. So 2 times 8 is 16, would give us 136. That's the closest value we get here. So the network address must be 136. And then we add the 8 to the 136 to get the 144 again, and we know that that is the next address block. Okay, so that's the magic number method. With the magic number method, just whatever the subnet mask is, you subtract that from 256, and that gives you your address blocks. It's pretty similar to the way that I was doing it previously. The way I normally do it is the octet that is being subnetted on, I'll write that out. So I'll write out 128, 64, 32, 16, and so on. And then I will figure out what the bit pattern is, and then I can put the line in, and I can see where the address block is at. But play around with this a bit, try out the different methods of doing it, and figure out which one you're most comfortable with, and that's one that you can use in practice and the one that you're going to use on exam day. Okay, let's move on to another example. So this example now will do a class A where we're going to subnet on the 4th octet. Previous example we just did was a class B on the 4th octet. This is going to be a class A on the 4th octet. And here we've been allocated 60.0.0.0/8. Same first question again. If we apply the subnet mask 255.255.255.240, so it's the same style of question but a different mask here, how many subnets do we have and how many hosts per network? So as usual, stop the video and I'll see you back in a second to give you the answer. Okay, so this example here, you see the other examples, we've been given the subnet mask as a slash notation. On the exam, maybe you'll be given it as a slash notation, maybe you'll be given it in dotted decimal. Here we were given it in dotted decimal, and we can figure out that 255.255.255.240, that is the same as a subnet mask of /28. Again, if you're not sure on it, you can just write it down. The more practice you get with these, though, you'll get really fast at doing it. Like if you look at the last octet there, 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248, plus 4 is 252, plus 2 is 254, and plus 1 is 255. And you see I was able to do that without even thinking about it. Once you've practiced this a little bit, you'll be doing exactly the same thing. So for our example, we had a /28, we put the line in, and we can see that we've got 4 bits for our host addressing. So that's 2, 4, 8, 16 minus 2 gives us 14 hosts per network. And now, because we were allocated a class A /8, we're going to have 20 bits for the network addresses, because the difference between the default /8 and the /28 that we're using is 20 bits. So 2 to the power of 20 works out at a little over 1 million subnets. Now, hopefully you wouldn't have to figure out a number as big as that on the exam, but if you had to, you'd still be able to do it. Again, you just start at 2 and just keep doubling it up all the way until you've done it 20 times. As usual, we've got part 2 of the question. So for the IP address, 60.15.10.75/28, what is the network address, the broadcast address, and the range of valid IP addresses? Pause the video and I'll see you back here with the answer. Okay, for this example, the line is after the 16 when we draw it out, so the network address is going to go up in multiples of 16. I can see by looking at the last octet of the address that I've got a 1 under the 64, and that's all. So the network address is going to be 60.15.10.64. And if I add 16 to that, the next network address will be 60.15.10.80. So our broadcast address here must be 60.15.10.79. And the range of valid host addresses fall between the network address and the broadcast address. So that's 60.15.10.65 up to 78. Another way you can do it is by using the magic number. And this is a way you can do it quite quickly in your head, especially if you were given the subnet mask in dotted decimal notation rather than in slash notation. But even if you have been given it in slash notation, you can still do it this way. You'll just need to convert it to dotted decimal first. So our example was a /28. And a /28, the subnet mask is going to be 255.255.255.240. We can figure that out by adding up the numbers. So a /28 is going to use the first 4 bits in the last octet. So 4 bits is going to be 128, plus 64 is 192, plus 32 is 224, plus 16 is going to be 240. Then what we do with the magic number is we take that number away from 256. So if the number we're subnetting it at is 240, then 240 taken away from 256 is going to be 16. So we know that the address blocks go up in multiples of 16. And with our example, it's asked us to figure out the network address for 60.15.10.75. So we just go up in multiples of 16 until we get to the closest subnet. So that would be 16, then 32. We can double that to 64. The next one would be 80. So 75 is between 64 and 80. So the network address must be 60.15.10.64. We know that the next block starts at 80, so the broadcast address must be 79, and the valid hosts would be 65 to 78. Thanks for watching. If you'd like to get the complete course, ad-free, right now, then you can enroll in my CCNA Gold Bootcamp by clicking the link above my head or in the description. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.